Hello mathematicians, puzzlers, and other curious people. In this video, which is part of the Pythagorean Intro to Number Theory study along, I'm going to be using a spreadsheet to find some Pythagorean triples. So here's what I've got here, and this is the LibreOffice Calc spreadsheet program. They're all pretty similar to each other though. So we're looking at numbers from 0 to 100. I'm going to start out with fewer numbers first, just to make sure that I've got something that works. I'll be able to extend this later. So what I'm going to do is I want to find out if 1, 1, something is a Pythagorean triple. So I'm going to set up a formula to calculate from that. So I'm going to calculate the product of 1 squared, the sum of 1 squared and the other 1 squared. Okay, well 1 squared and 1 squared, that's 1 and 1 that makes 2. This doesn't really tell me yet if that's a Pythagorean triple, so I'm going to add one more step here. So I'm going to take that and put it in parentheses, because I'm going to use it as an input into a square root function, sqrt. Okay, so now I see that I've got a non-integer number, so that is not going to be a Pythagorean triple. Now I need to look at extending this formula across my other numbers. Now let's make sure that those references went right. And see, the blue one went fine, but the red one did not. So instead of, let's see, it's C4, I want it to stay B4. And to make it stay there, I'm going to put a $sign on the B. Whoops, misclick. And now I'm going to extend that out. And that worked now. See how it's pointing straight at the 1 and straight at the 3? Okay, it looks like we're on the right track, so I'm going to go ahead and keep extending. And extending some more. And just a little further. And 100. Okay, so we're definitely on our way here. Now I notice that this takes a lot of columns. And, you know, really we're only interested in if what's in this column is an integer. We don't really care how many decimal places it has if it's not. So we can condense that down a little bit. Be careful of the rounding errors, though, through some of these. So I'm going to extend that back out and open those up just a little more so we can see which ones are integers and which ones are not. Okay, that'll do. Okay, so now we need to extend down. And once again, it's got that getting in the right place. So we want that to stay at row 3 for what it's referring to. So see how these already have row 3 in them? What I'm going to do is put the $sign in through there. But then let's see. Let's try dragging a few down and see if they point the right places. Okay, that one worked. Whoops. Let's try one more. $sign on the 3. Okay, so we found where we need to get that $sign. So onto the 3 there. Okay, so we need to go through and make sure they all have that. Now there might have been a more efficient time to do this. feel free to work on that as an investigation problem. See how it's got references in the right places. Okay. So it seems to me that maybe if we put a $sign here, that we could extend that out and save ourselves some repetition. Let's try it and see what happens. Okay, it looks like everything's going to the right place from that. So I'm going to delete these. They were good in their time, but we need to explore a little further now. And extend that out. And it looks to me like we need, yeah, more decimal places in the 100s, probably because it's more digits. Okay, now let's make sure this extends correctly. Okay, and we've got those references going to the right places, so it looks like it works. Okay, now here's the fun part. This is where we get to make the calculator, or the computer, but acting as a calculator, do a lot of math for us. Okay, and here we've got rather a shortage of inputs, but that's not a problem. There we go. And again, we highlight the things we want to extend, and then we extend them. Okay, now somewhere in this, we have all the Pythagorean triples with values up to 100, but we also have a lot of other junk that we just don't need. So how do we clean this up? Well, first of all, you'll notice that it's got that symmetry effect, like in this case, 1 squared plus 3 squared is the same as 3 squared plus 1 squared. So what we can do is go through and delete below the diagonal on each of these. And it takes a moment, but we'll get through this. We'll just keep going. And again, there might be a more efficient way to do this. Feel free to try to explore some upgraded coding. You might be able to make this happen automatically. But at least we can see how to go about it. We can probably do a few at a time to save scrolling. and then tidy it back up. Oops, I took too much. No problem, just put it back in. And we have it going along. Now you might notice that we're getting also some values that are over 100, so those definitely won't fit our requirements, so we can go ahead and delete them. So that can save us some time. So this is great. We're narrowing it down from a couple of different directions now. And we just keep going. It kind of makes an interesting shape, doesn't it? But we know these are repeats. Oops. Let's just make sure it's staying on a perfect diagonal. Okay. It's always good to check your work now and then. Okay. Okay, from here we've gone above 100, so we can just delete all the way over because we know it's not going to get any lower. Now we need to take out everything above 100. So first I'm going to go through and kind of take the first one of each row that's above 100 so that I can sort of see a shape in it that'll help me with, oh, whoops, misclick there. That'll help me with getting the right ones. Now, one thing that we're getting close to starting to deal with is the other requirement we had, that these be Pythagorean triples, which the Pythagoreans were very fond of whole numbers. They did not like irrational numbers at all, to the point of disbelieving that they actually existed and getting upset at one of their members who proved that they had to exist. Now, the exact details of what happened to that person, the the uh, the story that gets told might or might not be accurate. It's one of those things. But what we can see here is a lot of these are not integers. This one seems to be. The rest of these do not. We can certainly see which ones are not integers easily, because they've got all those decimal points. So I'm just going through and deleting everything that has a lot of decimal points, or that has decimal places at all, technically. Okay, I'm going to put that in bold. Now, we saw that it was possible to have rounding errors, so it would be a really good idea to check these once you find them. Perhaps we could check these by putting some more decimal places back onto that cell in the spreadsheet, or by actually doing the calculations. I'll leave it up to your own decision about how you deal with checking your work on this one. Just make sure that you do something that makes sense as a way to check it. 30, that sure looks like an integer. And the nice thing about doing this on a spreadsheet is the ones that are integers or close to integers, at least a rounding error for an integer, they just kind of jump out, because the decimals keep going and they sort of darken the space more than the integer that just stops does. I know it doesn't seem like it because there's still so much here, but we're really almost there. We've got a lot of work out of this spreadsheet, and it's great. Now, I noticed that in a lot of these rows and columns that there aren't any Pythagorean triples at all. So I'm going to start deleting some columns and some rows that are unneeded, because that's going to make it easier to read later on. Now, you might find out that for an investigation you want to do, you might find it useful to leave those in place instead. So I'm not saying anyone has to do this. I'm just saying it's a thing that I think would be useful for what I'm trying to do right now. And it's interesting, isn't it, how some numbers don't seem to be part of a Pythagorean triple. Now, is it that we didn't get yet, up to 100 to the numbers that they're compatible with? Or is it that they're somehow not compatible with any numbers for being in a Pythagorean triple? That's a good investigation question. And if you think this took a while in the spreadsheet, one thing you might want to do is try it by hand sometime. Or you might not want to. It's a matter of opinion, of course, but what I mean is, if you think that going through and dragging formulas around and deleting things that don't meet our requirements takes a while, well, yes, it does. But other ways take even longer. Okay, we're getting to the point where we need to start being a little extra careful, because it looks like there's nothing in that column, but then further down there is. So we need to make sure that we're getting down to where that diagonal shows up. Before we delete that column. Okay. Let's see. Nothing in that one that I want to keep. Nothing in that one. Nothing in that one. Ah. Here we go. So here's another Pythagorean triple that we seem to have found. Nothing in that one. Let's see. Ah, there's something. Whoops. And there's something. So you'll notice that many numbers don't seem to be part of any of these Pythagorean triples. And then some numbers are part of 2, like this one. Or even, let's see, we found 24 here that's part of 3 Pythagorean triples, in addition to however many it was the sum of, but I don't see any like that. So that could also be something interesting to investigate. Is there some kind of formula that tells how many Pythagorean triples a particular number is involved in? Or if not a formula, at least some kind of pattern. Nothing there. Ah, something here. Whoops. I see quite a lot here, in fact. What number are we on? 60. It looks like 60 is part of 5, if you count this one here. 5 Pythagorean triples. That's remarkable. Let's see, 61. I don't see any. 62. Still none. I see some in 63 though, so that's interesting. Whoops. Let's see, yeah, that needs deleted. And again, I know it looks like we've still got so much left to do, but we're really in the home stretch now. See how that's sort of coming up? We'll have less and less to check each time soon. Almost there, getting close. Wow, how many were there in that one? That seems like a lot. 2, 3, 4. Wow, 4 just on one. Okay. There we've got something. So this column we won't be deleting. Let's just keep going and find the rest of them. We're getting close. It seems like 85 shows up a lot. Because there it is, and then there again. Let's see, nothing in 79. In 80. There we go, we've got 82. And 89 and 100. Nothing in 81, in 82, also nothing, in 83, still nothing, in 84, there we go, another 85, interesting. Then also 91. 85. Interesting. It shows up as the first number so many times, but it shows up as the last number so many times, but not as one of the first two. I wonder if that was some that was down here, though, when going above 100. That's possible. 86, same thing. 87, same thing. 88, same thing. For 89, it looks the same. And the same for 90. Yeah, I really think what we're running into here is it's kind of hidden up against 100. Okay, for 91, same kind of a thing. For 92, same kind of a thing. For 93, nothing to highlight. For 94, likewise. For 95, the same. For 96, we've got 100. There. For 97, I don't see anything. For 98, we've got a way to make 100 with it, apparently. And I don't see anything in the 99s. Okay. So now what we have here, and can start carefully shifting things around, is again, we can start carefully deleting rows that also, like some of the columns, don't contain anything of interest. Making sure, of course, that we check. Oh, okay, there we go. There's something there. Maybe row 16 there. Let's see. Yep, that one can go. But not the next one, or the one after, or that one. Maybe row 20. Okay. Maybe row 22. Yeah. Okay. Okay, nothing for 37 or 38, so their rows can go. There's something. Maybe not for 41. Nope, that can go. Almost there. Okay. Nope, can't delete that. Can I? Yes, I can. Cool. Okay, now I notice we've got hundreds here, so that would have to be cut off. Okay, so I'm not seeing anything that we would be losing informationally from the rest of this. Because again, anything further out there would have to be above 100. So we can delete those rows. Not trying to have a bunch of redundant stuff. Okay, so now what we have here is a chart showing what seems to be all the Pythagorean triples with all three values below 100. And in fact, now that we've got this down to all integers, we can tighten those back up some more, so more of it will show at a time. There we go. We can get the whole thing showing horizontally, vertically most of it. Okay, and then if we want to know how many there are, I'm going to use the count function, and I'm going to count all the numbers within that grid. So it seems to me to be the case that there are 53 different Pythagorean triples with, made up entirely of numbers that are less than 100. So that's how I went about this. There are different ways, of course, that you could. As you can see, my chair slid down a bit. What can you do? But anyway, so here's how we found out how many Pythagorean triples there are below 100. Now, I'm not saying this was the best way. I'm not saying this was the most efficient way. I'm not saying that this is the most satisfactory way, especially for larger numbers that we want to go up to than 100. But it's a way we found, and it's a way we can make work. So let's continue our explorations knowing that we've got at least one way to deal with this kind of problem.